Fun little activity here. Write down a function as a Laurent series and then integrate that series expansion term by term. When you do that, do you recover something that's familiar to you? Pause the video and try and find out. So just for ease of notation, we're going to assume that our singularity is at the origin. So in that case, we can develop our function in the Laurent series around the origin as follows. First of all, lots of terms with negative powers. So let's start with a minus 2, 1 over z squared, and then a minus 1, 1 over z. And then we have a constant term, and then we have all sorts of terms with positive powers of z, a2, z squared, dot, dot, dot. So a series which extends towards both infinite powers of z and infinite negative powers of z. Let's now integrate this series term by term, and let's fall back on something that we already know. So one of the first things we did when we introduced contour integration is we looked at this particular integral here, the integral on a contour around the origin of a certain power of z. We figured out that most of the time this is 0 when n was different from minus 1. The only time we ended up with something that was non-zero, namely 2 pi j, is when we had n equal to minus 1. And at that time I said, okay, this seems like a very trivial result, but it will have profound implications later on. And this later on is actually now when we're talking about residues. Because what happens if we integrate the series term by term, and we assume that we can do that, then we end up with the integral of f of z dz being equal to, basically we get a whole lot of zero terms here. The only term that we still have is the term involving 1 over z. So this will be a minus 1 2 pi j, and then also for the other terms it's always 0. So the only thing that we're left with is this term related to 1 over z, which is precisely, of course, where the definition of residue comes in. So if we do this integration, we basically end up in a slightly different way with the residue theorem of a function having an isolated singularity.